All right, so this is number 6. Okay, so remember what you want to do here is if you look at this, you have 3 terms, and you want to simplify each of those terms. And what you want to do is simplify as much as possible as you go along the process. You won't be able to, for the most part, many of you won't be able to simplify each term right away. So just do as much as you can along the way. So what I would do first in that first term is see how you have that one square root? Break it down as a product of square roots. So remember, the square root of 7x to the 5th means the square root of 7 times the square root of x to the 5th. Y'all agree? Okay. And over here in the next term, you have minus 3x, and do the same thing. Square root of 45 times the square root of x squared. And then the last term, do the same thing. Minus 2, square root of 20, square root of x to the 4th. All right, so that'll be the first thing I would do. Then you simplify as much as you can in the next process, and then simplify again if you can along the next process. So do little pieces at a time. And so if you look at the first term, can I simplify the square root of 7?
No.
No, there's no perfect square other than 1 that goes into 7. So I cannot simplify that. So I'm going to just rewrite it as a square root of 7. Can I simplify the square root of x to the 5th? Yes. Why? You can simplify a radical expression that involves variables if the exponent is larger or equal to the index. Is 5 greater than or equal to 2? Yes, I can simplify that. Now, since I can simplify that, though, remember 5 is not divisible by 2. So you need to rewrite x to the 5th. How are you going to rewrite x to the 5th? X to the 4th times x. So remember, always rewrite it so you use the largest exponent less than 5 that is divisible by the index. And what's the index here? 2. All right, and then go into the next one. We'll come back and do more with this in a little while. Go to the next one. 3x. Now look at square root of 45. Is there a perfect square besides 1 that will go into 45?
Yeah.
Yes, 9. So that's square root of 9 times 5. Now look at the square root of x, square root of x squared. Remember when we did the square root of x to the 5th, I had to go a little bit further with that. I had to rewrite it as x to the 4th times x, the square root of that. But x, the square root of x squared, I know is exactly what? X. Now again, we're assuming that all these variables represent positive real numbers, so we don't have to worry about absolute values. Minus 2. Now what about the square root of 20? Can I simplify the square root of 20?
Yes.
Yeah, because what perfect square goes into 20?
4.
So that's 4 times 5. Can I simplify the square root of x to the 4th?
Yes.
Yeah, it's exactly what? X squared. All right, so that's where I'm at. So I'm doing as little bit as I can each time. Now let's continue on and simplify. All right, so I get the square root of 7. Now I'm circling the square root of x to the 4th because I know the square root of x to the 4th is what? X squared. That was the reason why we rewrote it. But it's x squared times what, though? Not x. Square root of x. Minus 3x. What's the square root of 9? So you're left with 3 what? Square root of 5 times what? X. And then minus 2, square root of 4. So that's 2 times 2, square root of 5 times x squared. So that's where I'm at. So it's a little tedious, quite a bit of work. Now, the one in your test or final is not that involved. So, but if you can do those, then you should be able to do the one that's in your test or the final. Now, look at that first term. You don't want to leave it like that. You know of a better way to write that first term. How are you going to write that first term? X squared first, and then what? Square root of 7x. All right, so you see how I have the square root of 7 times the square root of x? You know that since the index is the same, you can write as one square root. So the square root of 7 times the square root of x is the square root of 7x. So always write it as one square root. All right, so that's my first term. All right, let's look at the second. How can I write the second one then? All right, 3 times 3 is 9. I agree with that. This x times this x is x squared. So that's 9x squared. And what else? Square root of 5. Okay, I agree with that. That's correct. Now let's look at the third one. Minus, how are you going to write that? 4x squared, square root of 5. Now notice in each of those cases we prefer that the radical, the square root, be at the end. So you notice in each case you have square root of 7x, square root of 5, square root of 5. All right, now I have 3 terms. Are any of these like terms? Which ones? The last 2. Because now, remember, with regards to square roots, you have to have the same radicand, and I do. They're both 5s, right? Okay, but I also have variables involved. You see that? So since I have variables involved, I have to have the same variables and raise the same power in both terms. So here I have an x squared, here I have an x squared, so they're like terms. Now, what if I had this? What if I had 9x square root of 5 minus 4x squared square root of 5? Would those be like terms? No, those are not like terms. You have the square root of 5s, that is true, but what's the issue? This is x to the first, this is x to the second. So they're not like terms. Okay? All right, but these are here, so I can combine those. So I get x squared, square root of 7x. Now what's a negative 9 of these I'm circling and a negative 4 of these same things I'm circling? Negative 13? All right, and there's your answer. You're done. Okay, so that's number 6. So it's quite a bit of work you had to do there. All right, let's look at number 9. All right, so there's number 9. Okay, number 9, you have x times the cube root of, times the square root of x cubed, y to the 5th, plus 3, y squared, times the square root of x to the 5th, y. So again, just do just like we did, like we just did. Don't make it any difficult than it already is. All right, so I have 2 terms, and what I'm going to do to help me deal with this is I'm going to write that square root as a product of square roots. So I'm going to write this as x square root of x cubed times the square root of y to the 5th, just like I did before, and then plus 3y squared, and then what do I write? Square root of x to the 5th, and then what else? Square root of y. Right, so that's where I'm at. Okay, now I'm going to simplify just like I did over here. So can I simplify the square root of x cubed? Yes, because the exponent 3 is bigger than or equal to the index. Okay, so that's x, but how are you going to rewrite x cubed though? X squared times x. That's how I would rewrite it. Now look at y, the square root of y to the 5th. How are you going to write that one? Y to the 4th times y. Good. Okay, plus 3y squared. Same thing with x to the 5th. You're going to do it just like you did y to the 5th. You're going to say x to the 4th times x. Now, can I simplify the square root of y? No. Because what? Because the exponent, which is 1, is less than the index. You can only simplify this, guys. I'm going to write it as the a root of b to the m. You can only simplify this if the exponent of m is bigger than or equal to a. Then you can simplify. So I'm going to leave it as square root of y. All right, so notice I'm doing one little step at a time. Don't mess this up. Okay, so now I'm going to have this x. Now, what's the square root of this x squared? X, y'all agree? What's left, though? Square root of x. I'm circling the square root of y to the 4 because I know that's what? Y squared times square root of y plus 3y squared plus square root of x to the 4th. X squared, what's left? Square root of x, and then the square root of y. Okay? We're almost done with this. So now, at this point, how am I going to rewrite that first term? X squared. I always put the square root last. X squared.
Y squared.
Y squared. Square root of xy. Y'all agree? All right. And then the other one, you see how I have 3y squared x squared? You can leave it like that, but let's just put it in alphabetical order. So it'll be 3 what? X squared y squared times the square root of xy. All right. Are those like terms?
Yes.
Yes. So how many of the x squared y squared square root of xy's do I have?
2.
Nope. I have 2 terms, but how many altogether do I have?
4.
4. Okay, so that's number 9. Notes it is a tedious process, and you could easily mess up anywhere along the way. So it's important that you, if you need to, do it like we just did. All right, and then now, finally, let's look at number 10. Number 10. All right, number 10, you have negative 2x square root of 12xy squared plus 3y square root of 3x cubed minus 2 square root of 48 x cubed y squared. So negative 2x square root of 12xy squared plus 3y times the square root of 3x cubed, and then minus 2 times the square root of 48x cubed y squared. All right, now the one in your chest is not as complicated as these, but if it were, what would be your next step? Rewrite it? Okay, how would you rewrite the first term? Okay. Square root of x, square root of y squared. Good. Now the next one, 3y, square root of 3, square root of x cubed, and then minus 2, square root of 48, square root of x cubed, square root of y squared. Okay? And then, so first step is to rewrite it as separate square roots, as a product of square roots. And then now let's simplify each one as we can. So I have 2x. Now let's talk about the square root of 12. What perfect square goes into 12? So it'll be square root of 4 times 3. Can I simplify the square root of x that I'm pointing to? Nope. Leave it as square root of x. Can I simplify the square root of y squared that I'm pointing to? Yes, that's just what? Y. Good. So that's what I have so far. Just looking at each factor and seeing if I can do anything to those. Plus 3y. Can I simplify the square root of 3? No. Can I simplify the square root of x cubed? Yes. So I'm going to go ahead and rewrite it, though. At this point, I'm going to just say that's going to be the square root of x squared times x. Minus 2. Can I simplify the square root of 48? Yes. What perfect square largest that goes into 48? Okay, 16 times 3. Can I simplify the square root of x cubed? Yep. So I'm just going to go ahead, though, and rewrite it as x squared times x. Can I simplify the square root of y squared? Yep, that's just y. So that's where I'm at. So one thing at a time. All right, now let's go ahead and simplify some more. I have negative 2x. Now I see that square root of 4. What is that? So, okay, so I'm getting 2 what? Square root of 3, square root of x, y. Y'all agree? plus 3y square root of 3. Square root of x squared is x. You're left with square root of x. Minus 2. What's square root of 16? You're left with 3. Okay, I'm circling those I can deal with, right? So it's square root of x squared. X, what are you left with? Square root of x, and then y. All right, so no, we're not done, but notice what you have to go through each little part. So at this point, you'll get most of your points because you did quite a bit of work to get to that point. Now we got to simplify each term as much as we can. So if you look at this now, I have negative 2 times x times 2 times the square root of 3 times the square root of x times y. So there's 1, 2, 3, 4, 5. There's 6 factors here. A negative 2, x, 3, 2 rather, square root of 3, square root of x, and y. How else can you write that to make it look better? Negative 4, x, y, square root of 3x. Very good. Negative 4, x, y, square root of 3x. You all agree? Okay. Plus, what about the other one? 3xy square root of 3x. Okay, good. What about the last one? Negative 8 xy square root of 3x. Okay? So each of those terms becomes these. Now tell me something about those 3 terms. They're all alike. So I have 4 here, I have 3 here, and I have a negative 8. I have a negative 4 here, I meant to say. So a negative 4 plus 3 of those gives me what? Negative 1. So I have negative 1 right here. And a negative 1 and a negative 8 gives me how many? So I have negative 9xy square root of 3x. Okay? All right, so that should help you with the other problems. And the one in your test is much simpler than those. Okay, and the one same thing on your final. It's just usually they'll have one on your final, but it's not that complicated. So if you're able to follow along for the most part how to do this, you should be okay. All right? Okay, so that takes care of that little part.